biblical revelation of a young earth / creation. The first one is very little seafloor sediment. Okay? There's very little sediment on the seafloor. An estimated 20 billion tons of sediment is deposited on the ocean floor every year. 20 billion tons. Try to wrap your mind around that. With only about 1 billion tons being removed through the movement of tectonic plates. Yet the thickness of these sediments globally is only about 1,300 feet. Now, think about that. Of all the oceans around the world, with all these billions of tons of sediment being deposited, there's 20 billions of tons, only about 1 billion tons gets removed, and the thickness is about 1,300 feet. At this rate, 1,300 feet of sediment would accumulate in less than 12 million years. Okay? Now, how old does the secular science say the Earth is? Billions of years, right? And they would say that this process has probably been going on for at least 3 billion years. But just to tell you, 12 million years is enough time for 1,300 feet of ocean sediment to build up. Now, this does make sense within the context of a creation model that's based on the Bible. It makes sense that the sediment was deposited in the last 4,300 years since the Great Flood. Okay? So there you have the first evidence of a young earth or a young creation. There's not enough sediment on the seafloor for a 3 billion year old amount of sediment to have deposited. Okay? We only see 1,300 feet that's built up, and that could have built up in 12 million years. So, first thing that's not consistent with the secular worldview. The second thing we see, bent rock layers. And I want to pass this around to you so you can kind of get a mental picture of what we're talking about here. And a lot of the rock formations that we observe, and these are pictures from the Grand Canyon. You see rock layers laid down, and if you look on the page on the right, you'll see that it's laid down in a 90-degree angle. Okay? In many mountainous areas, rock layers thousands of feet thick have bent and folded without fracturing. Some rock layers in the Grand Canyon, supposed to be around 60 million years old, are bent in nearly 90 degrees without breaking. Now, this makes sense if the layers were laid down quickly in around a year's time. That's the creationist model of the Grand Canyon and how it was cut out. If that happened during the flood, that would make sense. If you had these young rock layers, you could have them standing up at almost 90 degrees. But if these rock formations, generally secular scientists look at the Grand Canyon and say that it's at least, I think, 40 million years old. If that were the case, how could you have these rock layers that are virtually standing up at 90 degrees without any breaking or fracturing? It just doesn't make any sense. Now, I will warn you, it's not to say that secular science doesn't have rescuing devices for these things. Okay, they do have, some explanations for these things. I'll just read you the one for this. So what solution do old Earth advocates suggest? Heat and pressure could make hard rock layers pliable, so they claim that this must be what happened in the eastern Grand Canyon, as the sequence of many layers above pressed down and heated up these rocks. Just one problem for that. The heat and pressure would have transformed these layers into quartzite, marble, and other metamorphic rocks. Yet the Tepete sandstone is still sandstone, a sedimentary rock. So if the secularists are right and heat caused these things to bend without fracturing, well, these rocks would have changed in composition, and they obviously haven't. So it's still not consistent with their model. But you're not going to get much admission of that. The number 3 evidence that we see, and this is a very important one. Carbon-14 in fossils, coal, and diamonds. What's carbon-14?
Kind of carbon found in life?
No, not actually. It is found sometimes.
Carbon's in everything, pretty much.
Carbon is in all living beings, that's true. But carbon-14, there are very, very small amounts that we find. There is a significant amount, enough that we can measure, but there's not very much of it compared to regular carbon. Carbon-14, what does the 14 refer to? What is that telling us? This is something you should have learned in a basic science class.
Well, isotopes of carbon.
It's an isotope of carbon, right? So an isotope is, you know, it's an element. It's still carbon, but it has a different number of protons in it, okay? So it is different from just regular carbon-12, all right? But carbon-14 is very rare compared to just regular carbon. Now carbon-14 has a half-life of only 5,730 years, okay? Keep that number in your head. 5,730 years is its half-life, and just what is a half-life? If you have, say you have 12 pounds of something, and you say it's half of some element, and you say that its half-life is 50 years. How much are you going to have in 50 years?
6 pounds.
6 pounds. That's the amount of time it takes for it to decay and leave only half of its original mass, okay? So the half-life of carbon-14 is 5,730 years. Here's the kicker, though. We find it in fossils and rocks supposedly hundreds of millions of years old. Now, if that carbon-14 was in those fossils and rocks, and these fossils supposedly are millions and millions, sometimes hundreds of millions of years old according to secular scientists, why is that carbon-14 still there?
Well, there was a lot of it to begin with.
Right. Now, we find it supposedly in rocks and fossils, supposedly millions of years old. Even if every atom of the earth were carbon-14, they would decay so quickly that none would be left after only 1 million years. Think about that. If every atom that composed everything in the earth were carbon-14, all of it would decay within 1 million years. Now, secular science tells us that the earth is nearly 6 billion years old. That's 1,000 millions. Okay? Does the math add up to you? Should there be any carbon-14 left anywhere? It should have all decayed, right? Except for the very small amount that's formed when you have cosmic rays hit atoms of carbon in the atmosphere, which is a very, very small amount. We're talking about carbon-14 that's actually in rocks and fossils. If all this stuff is supposedly hundreds of millions of years old, it should all be gone except for just the smallest traces. Okay, but it's not. We do find significant amounts of carbon-14, especially around uranium and thorium deposited in the earth. Okay, so carbon-14 content is more consistent with a young Earth model in which we assume a stronger magnetic field in the near past. Okay, the amount of carbon-14 that we actually observe in nature would make more sense if we follow the creation model. And the creation model tells us that the magnetic field of the Earth was stronger in the very near past. And we're going to get to the magnetic field in a minute, talk about it as one of the evidences. But why is that? Why would there be, why would a stronger magnetic field keep there from being more carbon-14? This one might be a little different.
Yeah.
Okay. Say you have, put this out of the way. Okay. Say you have atoms of carbon in different things, rocks, fossils. Okay, and you have radiation coming from the sun in the form of X-rays, cosmic radiation coming into the atmosphere, right? Well, what the magnetic field does, and I'm going to label the magnetic field B because that's what it's labeled in physics. What the magnetic field does is it kind of acts as like a force field against cosmic radiation and radiation from the sun. It actually scatters that radiation and makes it to where it doesn't have the effect that it otherwise would. Okay? So if you have a stronger magnetic field in the past, you're not going to have as much carbon-14 building up, because for carbon-14 to build up, you have to have that radiation coming in and hitting the carbon and changing it from C14 to C12. Okay? Because what it does is it knocks off protons.
Right.
It causes decay when you have that radiation actually come in and hit the atom atoms of carbon-14. Okay, so you see why that makes sense. If the magnetic field were stronger in the past, you would have less of this going on. Okay, and that's consistent with what we find. Okay, the next one we're going to look at, number 4. Very little salt in the sea. Okay, around 458 million tons of sodium mixes into the ocean water each year. Just, again, try to wrap your head around that. 458 million tons of sodium. Now, I can tell you, my doctor has told me to stay away from sodium. Sodium is very bad because it raises your blood pressure. And just the thought of 458 million tons of sodium kind of makes my blood pressure go up, I think. But anyway, it's being dumped into the ocean each year, this 458 million tons, but only 122 million tons is removed by natural processes. That's roughly 27%. Now, if the seas, as secular scientists propose, are around 3 billion years old, where is all the sea salt? If only 27% of the salt is being removed through natural processes out of the sea, you would expect the sea to be almost nothing but salt by now, over 3 billion years, right? So salty that no living creature could live in it, something akin to maybe like the Dead Sea. But that's not what we find. The oceans around the world are not that much. I mean, they have salt in them, but it's not as much as you would expect for a 3 billion year lifespan. Okay? Even if the seas originally had no salt, it would have only taken 42 million years at today's rates, not the 3 billion proposed by secular scientists, for that salt to build up to its current levels. Okay? Only 42 million years. So at the very least, secular scientists need to amend their timeline from 3 billion to 42, but there's even problems with that. Even the 42 million number has problems because it fails to, the assumptions that are put into accepting that number fail to recognize the likelihood that God created a saltwater ocean for his sea creatures. There are some sea creatures that need salt water.
Right, that's the same starting with 0 salt content.
Right. And there's really no reason for us to assume that, unless you're a uniformitarianist, or you believe that it was deposited there by purely natural processes. If God created the seas already with a certain amount of salt content, which is very likely, and then you had this year-long global flood that's described in the book of Genesis, dumping probably millions, if not hundreds of millions of tons of sediment laced with sodium into the ocean, then you would get the salt content that you currently have. It makes sense from that perspective. And you see the difference there. The creation model is consistent with what we actually find, but the secular model isn't. The secular model tells us that the seas are 3 billion years old. Well, we would expect to find a whole lot more salt in the oceans than we find. It's not consistent. But the creation model is. You do find the amount of salt that you would expect to find if the oceans are only about 4,500 years, or even if you want to say 6,000 years old. But you got to factor into there the cataclysm of the flood, because that would have greatly changed the composition of the ocean. Okay? Any questions about that? Make pretty straightforward sense? Okay. Number 5. Helium and radioactive rocks. I think we're going to get through this, most of it anyway. Helium and radioactive rocks. When I say radioactive, I mean, we've already kind of talked about it before. What is something that's radioactive?
Radium, plutonium.
Well, I mean, but just in general, when you say something is radioactive, what does that mean?
It's highly unstable.
It's unstable. It's releasing radiation, right? It's decaying from one thing into another. Helium and radioactive rocks. Why does helium produced from the radioactive decay of uranium and thorium still leak out of the Earth's rocks? Helium diffuses so rapidly. Remember, helium is what's called a noble gas. Okay, so it doesn't react with anything else really. It just goes out to the atmosphere when it's produced. Why does helium produce from the radioactive decay of uranium and thorium, those are two very radioactive elements, still leak out of the Earth's rocks? Helium diffuses so rapidly that it should have all escaped over 100,000 years. With all the uranium content we see in the Earth, helium is formed when those radioactive elements heat up, okay? They decay and helium is produced. Well, we still see helium coming out even now. Now, if that stuff's been in the Earth's crust for billions of years, why is helium still coming out? It should have already all been released into the atmosphere. But we still see active helium coming out of a lot of things. Specifically, let's see, but scientists believe that up to 58%, these are secular scientists, believe up to 58% of the helium in just uranium alone, not even counting the thorium, just uranium alone, that the uranium could have ever produced is still trapped in what's called zircon crystals. Okay, this is especially strange given that hotter rocks expel helium faster, and these zircons are typically around 387 degrees Fahrenheit. It just doesn't make sense that there would be any helium left. They should have already expelled all the helium through the radioactive process, but we still see helium there, and scientists are even saying that 58% of it is probably still there. It just doesn't make sense according to the secular worldview. Okay? Now, if you assume the Bible's account of creation, and that it only took place within the last 6,000 years, it does make sense that we would still have helium seeping out of the ground being formed from radioactive process. Okay? All right, let's move on to biology and paleontology. The next evidence we see is DNA in ancient bacteria. What's DNA? You don't have to quote for me exactly what it is, but I mean...
Deoxyribonucleic acid.
There you go. And what in just a broader sense, what is DNA? Tyler's very proud of that. I would be too, because I was trying to think, is it deoxy or deoxy or... But
it's really what makes up life.
yeah.
I mean,
If you had to sum it up,
I mean, that's really broad.
It's like genetics, like living
I
code.
mean, yeah,
there's the word I'm looking for.
Yeah,
Code, right? It's a code that's embedded in every living being that tells it how to grow, that gives instructions for the organs to grow. Everything about us, okay, everything about us is determined by our DNA, which in itself is a very strong argument for creation because the information contained within the DNA, how did it get there? Okay, information typically doesn't create itself. In fact, a lot of people believe that's impossible. But for some reason, we still think that DNA just somehow rose out of random processes. But anyway, that's a different discussion. But let me read you this about DNA in ancient bacteria. In 2000, the year 2000, scientists claimed to have resurrected bacteria, and they named it Lazarus bacteria, strangely enough, discovered it in salt crystal, conventionally dated at 250 million years. Okay? So these scientists, they find this, what they call ancient DNA, and they dated it about 250 million years. They were shocked that the bacteria's DNA was very similar to modern bacterial DNA. Now, let me just stop there. If you believe in the theory of evolution, okay, all of human evolution, according to these people, pretty much has taken place within that 250 million years. But you're going to tell me that they found bacteria with DNA that's almost identical to what we find today? How does that make any sense? Okay, it should be very primordial, right?
Bacteria's been slacking off.
Right. Now, I'm sure they have an answer for that. But 250 million years old, they say this bacteria is, okay? But they were shocked that the bacteria's DNA was very similar to modern bacterial DNA. If the modern bacteria were the result of 250 million years of evolution, its DNA should be very different from the Lazarus bacteria, based on known mutation rates. In addition, the scientists were surprised to find that the DNA was still intact after the supposed 250 million years. Think about that for a moment. DNA largely intact after 250 million years. Okay? You think about all the things that have taken place on Earth if that long time span is correct. how could that DNA stay intact all that time?
Hard.
It's kind of hard to believe. DNA normally breaks down quickly. You hear that? DNA normally breaks down quickly, even in ideal conditions. This is one of the biggest flaws with the secular worldview, okay? And just kind of to go off on a tangent, I guess, a little bit. Fossils. Think about fossils, okay? We're going to talk about fossils, soft tissue and fossils in a moment. But, you know, whenever secular scientists find a fossil, they always say, oh yes, this is hundreds of millions of years old, or this is millions of years old. But what they fail to tell you is the fossilization process is very rare. If you were just to leave normal bones out in a forest, okay, they're gonna disappear after a while. They're gonna be eaten up, they're gonna be destroyed, they're gonna be used by the organisms around it. Fossilization is a very rare thing, and it takes very special circumstances for fossilization to take place. Okay, we'll get to more of that in just a moment. Okay, even evolutionists agree that DNA in bacterial spores at dormant state should not last more than 1 million years. 1 million years. But they're saying that this Lazarus bacteria is 250 million years old. Their quandary is quite substantial. However, the discovery of Lazarus bacteria is not shocking or surprising when we base our expectations on the Bible accounts. For instance, Noah's flood likely deposited the salt beds that were home to the bacteria. If the Lazarus bacteria are only about 4,500 years old, the approximate number of years that have passed since the worldwide flood, their DNA is more likely to be intact and similar to modern bacteria. And I'd say that does make sense, okay? If that bacteria is relatively young compared to a secular time span, 4,500 years, then we would expect that bacteria to be very similar to what we find today, okay? Now I'll give you one of the common rescue devices for this particular argument. Some scientists have dismissed the finding and believe the Lazarus bacteria are contamination from modern bacteria. But the scientists who discovered the bacteria defend the rigorous procedures used to avoid contamination. They claim the old age is valid if the bacteria had longer generation times, different mutation rates, and or similar selection pressures compared to modern bacteria. Of course, these rescuing devices are only conjectures to make the data fit their worldview. Very true. Okay, let's move on to soft tissue and fossils. Soft tissue and fossils. And just again, you know, make sure I give credit where credit is due. We were reading this, I'm reading this from issue of Answers in Genesis, volume number 7, number 4, from October to December of 2012. And this whole issue pretty much is dedicated to the top 10 natural evidences we see of a young Earth. Let's move on to soft tissue. Okay. Ask the average layperson how he or she knows the Earth is millions or billions of years old, and that person will probably mention the dinosaurs, okay? Which nearly everybody knows died off 65 million years. Now, I can just tell you from personal experience, when I was a young boy, I loved dinosaurs. I loved reading about them. I loved learning about them. And just about any book that you could get your hands on, still today is the same case, is going to tell you that the dinosaurs died off 65 million years ago. Everybody's favorite dinosaur movie, Jurassic Park, you're going to hear that number used over and over again to talk about when the dinosaurs disappeared. A recent discovery by Dr. Mary Schweitzer, however, has given reason for all but committed evolutionists to question this assumption. Bone slices from the fossilized thigh bone, femur, of a Tyrannosaurus rex found in Hell Creek Formation of Montana were studied under the microscope by Schweitzer. To her amazement, the bone showed what appeared to be blood vessels of the type seen in bone and marrow. And these contained what appeared to be red blood cells with nuclei, typical of reptiles and birds. Red blood vessels and cells. The vessels even appear to be lined with specialized endothelial cells found in all blood vessels. Amazingly, the bone marrow contained what appeared to be flexible tissue. That would be impossible if these things were truly, you know, tens of millions of years old. I hope that's evident to you. Initially, some skeptical scientists suggested that bacterial biofilms, which in parentheses they say dead bacteria aggregated in a slime, form what only appear to be blood vessels and bone cells. Recently, Schweitzer and co-workers found biochemical evidence for intact fragments of protein collagen, which is the building block of connective tissue. This is important because collagen is a highly distinctive protein not made by bacteria. You see what they're saying there? These scientists were trying to rescue this by saying, well, it's just bacteria that's contaminated these tissue samples, and it makes it look like it's soft tissue. But the scientists said, no, wait a minute, we find these collagen cells, and bacteria don't have collagen, okay? And then he gives a reference to an article, see Schweitzer's review article in Scientific American, no friend of biblical creationism. December 2010, pages 62 through 69, titled Blood from Stone. Some evolutionists have strongly criticized Schweitzer's conclusions, really, because they are understandably reluctant to concede the existence of blood vessels, cells with nuclei, tissue elasticity, and intact protein fragments in a dinosaur bone dated at 68 million years old. Other evolutionists who find Schweitzer's evidence too compelling to ignore simply conclude that there is some previously unrecognized form of fossilization that preserves cells and protein fragments over tens of millions of years. Needless to say, no evolutionist has publicly considered the possibility that dinosaur fossils are not millions of years old. Now, the quickest way in our modern culture to be made a pariah, to be denounced and to be called a wacko, is to say that dinosaurs and humans lived at the same time. Okay? Now, this would seem to corroborate that. If there's still living tissue in a Tyrannosaurus rex bone, I'd say that's very good evidence that that Tyrannosaurus rex didn't live very long ago according to secular timescales. Okay? All right, quickly, as we're getting close on time, the other three things that we say, I'm just going to cover these very quickly. Number 8, rapidly decaying magnetic field. Okay, when we observe the magnetic field around the Earth, and we talked briefly about it a few minutes ago, the thing that protects us from a lot of cosmic radiation and the sun's radiation, that magnetic field is rapidly decaying. Okay, we've been able to observe this. Now, think about that for a moment. If the magnetic field is rapidly decaying, in 3 billion years or 6 billion years, should not the magnetic field around the Earth be completely gone? But it's not. We still see a magnetic field, and it's decaying very rapidly. Now, let me just say, that doesn't bode well for life on Earth. When the magnetic field completely goes away, we're going to see some results from that. But the fact that it is decaying rapidly, we can observe it decaying rapidly now, is very good evidence that the Earth is not billions of years old, because if it were, the magnetic field would be gone by now. Okay? There would be no magnetic field. But we still observe it. Number 9, the faint sun paradox. Let me read to you briefly from here. The faint sun paradox. And again, these examples are from physics and astronomy. Evidence now supports astronomers' belief that the sun's power comes from the fusion of hydrogen into helium deep in the sun's core, but there's a huge problem. As the hydrogen fuses, it should change the composition of the sun's core, gradually increasing the sun's temperature. If true, this means that the Earth was colder in the past.
Global warming.
Yeah. In fact, the Earth would have been below freezing 3.5 billion years ago when life supposedly evolved. You catch that argument, okay? If the sun actually evolves the way secular scientists say it does, as far as the fusing of hydrogen to helium, the sun should have been much colder in the past. In fact, it should have been it's so cold that the Earth was colder, so cold that it wouldn't be possible for life to develop on Earth 3.5 billion years ago. The rate of nuclear fusion depends upon the temperature. As the sun's core temperature increases, the sun's energy output should also increase, causing the sun to brighten over time. Calculations show that the sun would brighten by 25% after 3.5 billion years. This means that an early sun would have been fainter, warming the Earth 31 degrees Fahrenheit less than it does today. That's below freezing. But evolutionists acknowledge that there's no evidence of this in the geologic record. They even call this problem the faint young sun paradox. While this isn't a problem over many thousands of years, which our worldview teaches, it is a problem for the world if the world is billions of years old. Okay, and then the last one, short-lived comets. A comet spends most of its time far from the sun in the deep freeze of space, but once each orbit a comet comes very close to the sun, allowing the sun's heat to evaporate much of the comet's ice and dislodge dust to form a beautiful tail. Comets have little mass, so each close pass to the sun greatly reduces a comet's size, and eventually comets fade away. They cannot survive billions of years. I'm not going to be able to go into all the details of that, but think about that. These comets, what's the big comet that comes around about every 76 years? Halley's Comet. Okay? Now, if the universe is really billions of years old, the solar system supposedly is 6 billion years old or more. These comets continue to come around. Okay? Shouldn't they all be gone by now? Because every pass around the sun, these comets lose a great deal of their mass. You see the argument that's being made here? Two other mechanisms can destroy comets: ejections from the solar system and collisions with planets. Ejections happen as comets pass too close to large planets, particularly Jupiter, and the planet's gravity kicks them out of the solar system. While ejections have been observed many times, the first observed collision was in 1994 when the comet Shoemaker-Levy 9 slammed into Jupiter. I remember that, seen that on TV. I don't remember if you guys remember that or not. Given the loss rates, it's easy to compute a maximum age of comets. That maximum age is only a few million years. Obviously, their prevalence makes more sense if the entire solar system was created just a few thousand years ago, but not if it arose billions of years ago. That's where we're going to have to end. We got through all 10. So next week,